I don't know if anybody is using the but every class that I've given has been posted on Blackboard. There's a YouTube of each class, like a YouTube of each class. It's recorded, and if you feel you want to go over it, or if you missed a class, you can always review it in the recording section of Blackboard. Let me just mention again, our final exam is on December 15th. It's on Blackboard. You do not get onto Zoom. It's not on Zoom. It's on Blackboard. It's going to be posted from 9 to 11 a.m. And I'll probably open it up a little bit earlier and leave you a few minutes extra at the end. But basically, it's on December 15th, which is a Thursday, between 9 and 11. If that does not work for you, for some reason, if you have a conflict, you have to let me know so I can make other arrangements. Okay. These two.
Wait, I'm sorry. Can you repeat that, please?
Yes. The final exam is on December 15th, which is a Thursday, which means between 9 and 11, which means you have to be available to sit for the exam then. It's on Blackboard, the way the midterm was, the way the pre-final is, the way the practice midterm, the practice final, they're all on Blackboard. Our final exam is also going to be on Blackboard, but specifically on December 15th from 9 to 11. If you are not available there, if you have some sort of conflict, you have to let me know in an email, because I won't remember, just tell me in person, and I will have to set up a special time for you. So if you cannot do it at that time, email me when you would be able to do it so that I can set it up for you. Is that clear?
Yes, that's clear. Thank you.
Okay. Okay, so let's start doing these two examples in systems of equations. Again, we're starting each class now with a review of questions that will from previous chapters that we've done. So we're doing final review as we continue learning. We have, besides this next coming week, we have the following Monday and Wednesday. Our last class, as far as I know, is the Wednesday, December 14th is our last day of class. And that means after today, we only have 5 more classes. So we have to review and finish up. Okay, so this first question, we want to solve this system of equations where we're given x equals 2y and 2x minus 3y equals 3. And that looks like a good setup to do what we call the substitution method, because our first equation is telling us that what x is in terms of y. We're explicitly told that x equals 2y. So in our second equation, where I see the y over here, I can replace, where I see the x, not where I see the y. It's telling me what x is. Where I see the x, which is right over here, I can replace the x with 2y. So this is going to be 2 times 2y. Instead of our x, we're using 2y minus 3y equals 3. And now we just have a regular equation in terms of one variable. 2 times 2y is 4y minus 3y equals 3. And 4y minus y is y equals 3. So we already know what the value now of y is. But when you're solving a system equation, you don't just give the value of the one variable, you have to do both variables. So we have to figure out what x is, but we know that from the original equation that x equals 2y. So if y is 3, x is 2 times 3, or 6. So my correct answer is choice B, 3, 6. You see how careful you have to be on these, because the only difference between the answers is the sign. So you must be careful to make sure you're looking, do the right sign. I see both people who sent me the answer got B as their answer. So that is an equation where we use substitution. The second one, no, this is where we're working. The second one, we have x minus y equals 5 and 3x minus 8y equals 5. That is the setup that makes more sense in this case, is a good setup to use what we call the elimination or addition method, because we have the x's, the y's, the equal sign, and the number all lined up. And what we want to do is eliminate one of the variables, and it really doesn't matter which one I decide to eliminate first. It's my choice. Let's say decide I want to eliminate the x's. That means I have to multiply them by their opposite coefficients. So the top equation I'll multiply by the 3. And the bottom equation, well, there's no number in front of the x, that means it's a 1. But since both of these are positive, they're both the same sides, I have to use a negative sign in one of them. And it doesn't matter which one I use as a negative sign with. Don't use it with both, because the idea is to get the same number as a coefficient, but one being positive and one being negative. So therefore, even if I had gotten rid of the y's, I still would have had to make one number positive and one number negative, because they both have the same sign. The only time I don't have to use a negative with either on either one of them, it's either I use a negative or I don't use a negative with one of them. If I don't have to use any negative, if one of the variables already has a negative and the other one has a positive. Okay, so if I multiply my top equation by 3, I'll get 3x minus 3y equals 15. Don't forget, you have to multiply everything, both sides of the equation, by that 3. The bottom equation, we're multiplying by -1, so that's going to give us negative 3x plus 8y, because negative times negative is positive, equals -5. Again, we multiply through that -1. And notice now when we add these two equations down, 3x and minus 3x cancel out. We forced that to happen because they now have the same number in front of them, but one is positive and one is negative. Going on, when I add negative 3y plus 8y, it gives me 5y. And when I add 15 and minus 3, I get 10. So when I divide by 5, I get y equals to 2. Now, there are two answers that have y equals to 2. So I have to go back to either one of the original equations and replace the y with 2. So let's say I go to the first equation. So I'm going to do x minus, well, now I know my y is 2 equals 5. And to get the x, I'm going to bring the 2 to the other side. So that'll give me x equal to 7. So my answer is 7, 2. Which is choice A, and the people who did it actually got that right as well. Thank you for the people who sent me answers and that they are correct answers. Okay, so I'm gonna do one more example from this chapter, and then we'll go back to our new material. Again, let me just, before because I see some more people have joined. The final exam is Thursday, December 15th from 9 to 11 on Blackboard, not on Zoom, on Blackboard. You open up your Blackboard account, and just the way you've been doing your practice, midterm and final, and the actual midterm, that's how your final is going to be. I know the practice final has 40 questions, but I'm pretty sure that the actual final has a total of 30 questions. So, and we've done most of the work. We're on our last chapter. Okay, let's just do one more example like this that has to do with systems of equations. This one is going to be a word problem. Again, I'll give you the facts of the word problem, and I'll give you time to work it out, and we'll see if you come up with the right answer. Okay. Here's the question. Tickets to a local movie were sold for $10 for general admission. Just call it general. Well, each ticket to the movie for general admission is $10, but for seniors, it's just $6 each. So we know how much each type of ticket costs. One type, the regular tickets cost $10 a piece. The senior tickets cost $6 a piece. 190 tickets were sold. And the total amount of money that they made from selling all these tickets was $1,740. If there is a dot with 2 zeros, you can just ignore that, because this could be written 6.00. And the question is, this is the total amount that was collected. How many general admission tickets were sold? And here are your choices. Multiple choice, 40, 150, 30, and 109. So I am giving you a few minutes to work on that to see if you can do that. It's also a system of equations, but it's a word problem. While you're doing this, I'll take attendance. I'll look on the participants list. Okay. Okay. Naya, I see you're here.
Good morning, Professor.
Good morning. Isis, I see you're here. Caleb, of course, you're always here. Thank you. Some people have very good attendance. They're always on early. It's a pleasure. Okay, Kiana. Oriana. Shania,
I'm here.
yeah, I see. Tahira. I'm just writing, if you hear your name called, it means that I know you're here. And I think that takes care of everybody. We're 7 people. 1, 2, 3, 4, 5, 6, 7. Okay. Okay, when you finish it, of course, pick the correct answer. Well, I'm giving you 2 more minutes. I don't see anybody have any answers yet. Well, let's see if anybody comes up with an answer. Okay, let's try and do this example then. Remember what I told you about doing a word problem? It's a good idea to write out specifically what your variables are going to represent so that you can write your equations more easily. So there are two things that we're talking about. We're talking about general admission tickets. So let's call X. Now, what's the question? How many general admission tickets were sold? So let's call that X. The number of general admission tickets that were sold. That's going to be our X. But there's another thing. There's a Y. That, because it's telling us also about the number of senior tickets that were sold. So we have two types of tickets that were sold. The number of general admission tickets we're calling X. The number of senior tickets we're calling Y. Notice I'm not just saying X is general admission tickets or Y is senior tickets. I'm being very specific. I'm talking about how many of them they were sold. So let's go and read the next piece of information. We were told that 190 tickets in total were sold. So that must be that our equation will be X plus Y equals 190. Because how many tickets were sold? The combination of the general and the senior tickets is the total number of tickets that were sold. Notice I don't put any numbers in front of the X and the Y because I'm not talking about money. I'm just talking about how many, not about the price of each ticket. But the second bit of information that we have has to do with how much money was collected. So in that equation that talks about the money, we also have to include the price of the tickets. So for the price of the amount of money they're going to get from the general admission tickets is going to be 10x. Let's say 100 general admission tickets were sold. Then the amount of money they got from that was 100 times 10. And the amount of money they got from the senior tickets was 6Y. And that gives us our total. Notice the 10 and the 6 and the 1740 all go together because they all are referring to the money part. And we're going to do the same thing we did with our previous example. We're going to get rid of one of the variables. And since they specifically asked for how many general admission tickets were sold, I want to keep the X, that's the one that has a general admission, and eliminate the Y's. If I eliminate the X's and I get the value of Y, I can always figure out the X, but don't forget to answer the question that they give you. So multiplying, since I want to get rid of the Y's, I'm going to multiply the top equation by 6, the bottom equation by 1. And again, since these are both positive, I'm going to use a negative with one of them. And again, it doesn't matter which one I use the negative with, I decided to put it on the top. So my top equation becomes negative 6x minus 6y, and now I'm taking out my calculator because I'm allowed to use a calculator, so let's get used to it. And negative 6 times 190 will give me negative 1,140. Multiplying the bottom equation by 1 really doesn't change anything, so it stays 10x plus 6y equals 1,740. And now I add these two equations. So negative 6x plus 10x gives me positive 4x. the negative 6y and the positive 6y cancel out. That's what we are trying to make happen. And I'm going to add the negative 1140 plus the 1740, which gives me a total of 600. And remember, it's a positive 600 because the larger number is positive. And then I'll divide by 4. And 600 divided by 4 is 150. So 150, which is choice B, general admission tickets were sold. You would have, there almost invariably is a question of this type on the final exam. This is basically what we learned in chapter 3. Monday we'll go over chapter 4. In the interim, let's go back to the topic that we had been talking about earlier. We started talking about, we're going to be doing the last chapter of the book that we haven't covered yet, which is called Exponential and Logarithmic Functions. And we started, obviously it has something to do with exponents. So we started reviewing our rules for exponents. And I just want to give you, let me get my book, a couple of problems that have to do with exponents. I'll do one, then I'll give you time to do. So let's say I had a question that looks like this. Suppose I gave you something where there's a lot of different types of exponents in the example. X to the negative 2 to the third power, X to the third to the negative 2 power, and over X to the 10th. And we want to simplify this. We want to get it down to as small a expression as we possibly can. Now, if you recall, if you were here on Wednesday, what we said is wherever there's a parentheses, the first thing we want to do is get rid of the parentheses. Now, if I have an X to the negative 2 raised to the third power, our rule is when you have two exponents on a number, an exponent on the inside and an exponent on the outside, what you do to those two exponents is you multiply them. So this X to the negative 2 to the 3 will become X to the negative 6, because negative 2 times 3 is negative 6. This X to 3 to the negative 2 also becomes X to the negative 6. And there's nothing to do on the bottom because there's only X to the 10. So once we've gotten rid of our parentheses, and if there were two letters and exponent on the outside, we'd apply that exponent, would distribute the exponent to both letters. We then look, now we have a simplified example where there's no parentheses. So then we start looking at the sign of the exponent. An exponent that's positive just means, let's say if I have x to the 3, it just means that x is multiplied 3 times. But an exponent that's negative is telling you that you have to take the reciprocal of a number. In other words, if I have x to the negative 2, that really means 1 over x squared. So the negative is taking the base, the number, and putting it into the denominator. That is the effect of a negative exponent. Obviously, saying x to negative 2 doesn't mean you're multiplying it negative 2 times. What you're doing is you're taking the reciprocal, you're getting 1 over x, and you're multiplying that 2 times. 1 over x times 1 over x becomes 1 over x squared. So when you have something like that in a expression, and you want to simplify, if it's already got a fraction, fine, this already has a fraction. If it doesn't, then put a fraction line, because negative exponents indicates that you're going to have fractions. Okay, this already has a fraction line. Here's my example. I'm rewriting it. What I'm going to do is take any letter or variable that has a negative exponent, which will tell me it has to be a reciprocal. I'm going to move it. Because taking the reciprocal simply tells you that when you're taking the reciprocal, you're moving things. You're taking things that are on top and moving them to the bottom. You're taking things on the bottom and moving them to the top. So where I see this first x to negative, negative 6, I know I have to take the reciprocal, which means I'm taking this number that's in the denominator, in the numerator, it's in the top, and putting them in the denominator. That's all you have to do when you see a negative exponent. I go to the next thing I see. I get another x to the negative 6. Again, that's going to go to the denominator. That takes care of my numerator. Let's go to the denominator. The denominator is x to the 10th. Now that is a positive exponent. Means I don't want to take its reciprocal, which means I want to leave it in the same position it was in. So since it's in the denominator, it stays in the denominator. Now, notice this was a fraction line. I had to put in that fraction line. There's nothing left on top. That doesn't mean it's 0. It means it's 1. When after you moved it, if everything has been moved and there's nothing left, it's not, we're moving this, it's like a division. It's not like a subtraction. So we leave the numerator to be 1. And all we have to do now is look at the denominator. And we have to multiply x to the 6 times x to the 6 times x to the 10th. They're all next to each other, so that means they're being multiplied. But when we're dealing with exponents, when we multiply, what we do to the exponents is we add them. So I add 6 and 6 is 12. 12 plus 10 is 22. So my denominator becomes x to the 22. And my final answer in simplest form is 1 over x to the 22nd. So when you're simplifying these expressions, you want to make sure that you're left with only positive exponents and that anything that can combine gets combined. Okay, I'm going to do one more question and then I'm going to give you a question to try. I'm gonna erase this one and I'm gonna do another one now. So x to the -2, y to the 8th, to the 4th power, over x to the 4th, y to the 7th, to the 0 power, and x to the -2, y to the 5th, to the -2. Okay, so let's see if we can simplify this as much as possible. Now, first of all, on the top, I see x to the -2, y to the 8th, all raised to the 4th power. Now, that means I have to apply the 4 to both the x to the -2 and to the y to the 8th. And remember, when you have an exponent on top of another exponent, something has two exponents, what you do is you multiply the two exponents together. So that'll give me x, -2 times 4 is -8, and y, 8 times 4 is 32. That takes care of the top, as in terms of removing the parentheses. The next thing now I'm going to the denominator, I have an x to the 4th and a y to the 7th, all raised to the 0 power. Now, we said the other time, anything to the 0 power is just the number 1. I don't have to do any more work. I don't have to do 4 times 0, which of course will be 0. Everything will turn out to be 1. So anytime I get something to the 0 power, I'm going to right away replace it with a 1. Going on to the next thing, x to the -2, y to the 5th to the -2 will give me x to the 4th, because -2 times -2 is 4, y to the -10. Okay, so things are already look a lot simpler because I don't have those parentheses. After I remove the parentheses, the next thing I do is I start moving things around. Anything that has a negative exponent has to get moved. If it's on top, it gets moved to the bottom. If it's on the bottom, it gets moved to the top. Anything that has a positive exponent stays where it is. So this x to the -8 goes to the bottom, and it becomes x to the 8. The y to the 32 stays on top because it already has a positive exponent. The 1 I can just ignore because 1 times anything is just this. So the next thing I see is an x to the 4th. That stays on the bottom because it has a positive exponent. But the y to the -10, that gets moved to the top because its exponent is negative. Which gives me, now I have y to the 32 times y to the 10. So 32 plus 10 gives me y to the 42. And the denominator is x8 times x4, which gives me x12. Now, these are not the same base. This is the base of y and this is the base of x. So I can't combine that any further. So that's the answer. Okay, I'm now going to put a similar question on the board. And we're going to see if you can do that question. I'm gonna, everybody okay? Can I erase this? See, Jean, you just joined us. And anybody else? And Alvaro, okay, let me just add you to the, let me put this on the board and I'll add you two people to my attendance. So here's the question. Parentheses, a squared b fifth -2 times a to the -4 b squared to the 0. And that's all over a to the -2 b to the 4th to the 2 power. See if you can simplify that as much as you can. There should be no negative exponents. Okay, let me. Okay, I think we should try and do this together. And see if we can simplify this example. Again, the first thing we want to do is to get rid of those parentheses. Now, the first parentheses has a -2 on the outside, so I'm going to have to multiply each of the exponents on the inside by the -2. If a letter does not have an exponent, remember it's understood that the exponent is 1. When no exponent is written in, it means the exponent is 1. But these all have exponents, so the first thing we're going to do is 2 times -2, so that'll give me a to the -4. Then it's b⁵ to the -2, that'll give me b to the -10. The next thing next parenthesis we see is an a to the -4th, b², but it has a 0 exponent on the outside. And remember, we just said when something has a 0 exponent, it's just equal to 1. Anything to the 0 exponent, doesn't matter how complicated it looks. If there's a 0 exponent, it means it's 1. On the bottom, we're going to get an a to the -4 and a b to the 8th. Because -2 times 2 is -4, and 4 times 2 is 8. So now we've gotten rid of all the parentheses. We're now going to move any letter that has a negative or number that has a negative exponent has to be moved. Anything that has a positive exponent stays where it is. So here's draw my fraction line. My a to the -4th has to be moved to the denominator, and I get a to the 4th in denominator. The b to the -10 becomes a b to the 10 on the bottom. The 1 just stays on top. Doesn't move, its exponent is 1, it's a positive, it doesn't have any exponent, means it's a positive 1. The a to the -4 goes on top. And the b to the 8 stays on the bottom. So now let's see what we can do. First of all, with the a's, I have an a on the 4th on the top and an a on the 4th on the bottom. Now, when you have the same letter on the top on the bottom, you're going to have to cancel out, cross out the one with the lower exponent, and subtract that exponent from the higher exponent. Now it turns out that these are both a to the 4th, so they both cancel out. But you always cross out the one with the lower exponent, and if this would have been, let's say, a b to the 6th, I would have been 6 minus 4, and it would have given me a to the 2. And the letter always stays where the higher exponent is. In this case, they both canceled out. These b's are both on the bottom, so that's going to give me b to the 18th in the denominator. So I'm left with just a plain 1. Remember, don't leave it blank, don't ignore it. If there's nothing left, then you have to put a 1 there. We have the 1 anywhere from before. So my final answer in simplest form became 1 over b to the 18th. Okay. So they can get complicated because there's so many, you have to really do it carefully because there's so many letters, but they usually reduce to really quite simple examples. Okay, so we've talked about regular exponents and the rules for regular exponents. We've talked about negative exponents. Notice the rules are basically the same in terms of adding exponents, etc. You could also have something with the exponent is a fraction. So let's talk about what do we mean by fractional exponents. And we had just recently finished a whole chapter on radicals, on square roots. And if you remember, let's say if we this is what we call the radical or sign or the square root sign. Something like this is called the square root of 25. And of course, we know that that is equal to 5. Something like this is called the third root or the cube root of 8. Once there is a number in this check mark box, that is called an index. If there's no number there at all, it's understood that the index is 2. And what it tells you is how many times a number is being multiplied to give you this number. The third root of 8 is, what number do we multiply 3 times to get 8? Of course, that's the number 2. You could have even something like this. The fifth root of, well, let's not do the fifth root. Let's say I had something like this. The fourth root of 81. What number times itself 4 times will give you 81? Now, if they give you these type of questions, the numbers are going to be easy. The square root, we have a square root button on our calculator. Some of the better calculators have cube roots and fourth roots, but you don't have to worry about it. It'll only be an easy number like 2 or 3 or 4 or 5. It's not going to be more than that. If you notice, when you multiply 3 4 times, you'll get 3 times 3 is 9. 9 times 3 is 27. 27 times 3 gives you 81. The fourth root of 81 happens to be 3. So these numbers in the radical, in the check part of the radical sign are called the index. And again, if no number is there, it means it's just a plain square root. And if I ask you, what's the index here? The index would be 2. It's understood that you're multiplying the number 2 times. Now, there is an alternate way of writing this using exponents. Instead of using the radical sign, we could write 25 with an exponent of 1/2. Put 1 over the index, it means the same thing. 25 to the 1/2, this is a definition. This is how we're going to use exponents. It's can't prove this. This is how we're defining fractional exponent. A fractional exponent means a radical where the denominator of the radical, the denominator of the fraction is the index of the radical. So 25 to the 1/2 power also means 5. If you want to use your calculator to work out radical, you're probably better switching them to fractional exponents because your calculator can put any exponent. If you don't know how to use your calculator for exponents or things of that nature, send me an email and I'll make up a time to meet with you and discuss your calculator. You'll have to show me a picture of your calculator as well. Okay, similarly, instead of writing the cube root or the radical with a 3 index of 8, we could have written that as 8 with a 1/3 exponent. That also equals. These two things are the same. And obviously, the fourth root of 81 could be written as 81 to the 1/4 power. What's the advantage of using the exponents as opposed to radical sign? Is that exponents work like exponents, whether they're whole numbers, 0, fractions, positive, negative. All the rules of exponents always apply. So if I were to ask you something like this, I'm just looking for, I'm trying to offer. Now I'll make one up. All right, let's say I gave you something that looks like this. Let's say I ask you to figure out the value of 5 to the 4th power raised to the negative 1/2 power. Now, if you remember what I said, when you have an exponent, something in a parentheses, with an exponent on the outside, you want to get rid of the parentheses and you do it. This is, you're going to use exact same rules by multiplying the two exponents together. Once you have a number with an exponent raised to another exponent, you're going to multiply the two exponents together. So you're going to have to multiply the 4 by the negative 1/2. Now, either you could do this on your calculator or you could do it in your head. Remember, 4 really means 4/1, and you multiply 4 times -1 is -4/2 times 1 is 2. So you get -2. 4 times -1/2 is -2. So this really means do 5 to the -2. But we can even go further with this, because first of all, it has a negative exponent, which means that I'm going to have a fraction. What was originally on the bottom here is obviously a 1. We don't usually put write this as a fraction, but it is over 1. When I look at this 5 to the -2 will become 5 to the 2 on the bottom, because it has a negative exponent, just as we've been saying, it has to be moved to the denominator. We have to take its reciprocal, which means there's nothing left on top, so we put 1/5 squared. And since I know what this number is, this would be an x, I'd leave it like that, but 5 squared I know is 25. So this is 1/25. So I basically use all the rules that apply to exponents, adding, subtracting, multiplying, dividing, and remembering that if I have a fractional exponent, what that fractional exponent means is to take a radical. So let's say I gave you this example. 8 to the 4th power raised to the 1/12th power. I'm going to give you time to try that one. Okay, let's work on that question. Just like I did before, when I have something with an exponent raised to the second exponent, I have to multiply those two exponents together. So I have to multiply the 5 times the 1 over 12, the 4 times the 1 over 12. Now this really means 4 over 1. So this becomes 4 over 12, which reduces to 1/3. In other words, what I'm asking you to find is 8 to the 1/3 exponent. And now we have to remember, a fractional exponent is the same as a radical, with the denominator of the fraction is the index. So this is the same as saying radical index 3 of 8. In other words, this is the same as saying, what is the cube root of 8? What number times itself 3 times gives you 8? Well, I think everybody knows that that answer is going to be 2. Remember, if they give you these numbers, they're going to give you easy numbers, and you're going to have multiple choice, so it'll be able to figure out the answer. Okay, so now we're going on to, that was a preparation for chapter 8. We're going to start with chapter 8. Now, remember what I said chapter 8 is. Chapter 8 is called exponential functions or exponential equations and logarithms. So we're going to talk today about something called exponential equations. And then we'll go next time into logarithmic equations or functions. Okay, so what does an exponential equation look like? An exponential equation could be something like this. 2 to the x equals 60. It's called an exponential equation because the variable, the x, the unknown, is in the exponent. We've talked about things like this. X squared equals 16. That we did talk about. That isn't an exponential equation because my exponent, I know what it is. The variable is the base. Obviously, if we have x squared equals 16, if you remember, we solved that by doing plus or minus the square root of 16, which means that x could be either positive 4 or negative 4. 2 answers, because when you have x squared equals a number, you can get 2 answers. We talked about it. This was a quadratic equation, but this is an entirely different thing. This is something that we want. We know what the base is. What we're trying to find out is what is the exponent. Now, on a multiple choice test, of course, that's not so difficult because you could just try each of the answers. Let's say one answer is 1. Well, 2 to the 1 is not 16. You could try the answers, but I'm going to show you how to do this if it's an open-ended question. Try and write both numbers to the same base. This number 2 to the x is written in base 2. What do I mean it's written in base 2? It's written as 2 to some exponent. Try and write the 16 in base 2. In other words, can that be written in base as 2 to some exponent? Well, how do I figure it out? I'm going to use my fingers or my calculator. 2 times 2 will give me 4. 4 times 2 will give me 8. 8 times 2 will give me 16. I'm lucky I got to 16. How many times did I multiply the 2 to get to 16? Went 4 times. 16 could also be written as 2 to the 4th. We'll talk about later in this chapter what happens if it would have been, let's say, 10, and I went 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and I never hit that number. Then we have to do it a different way. But today we're talking about when we can take both numbers and put them in the same base. Once they're in the same base, then they can be solved, because if they're the same base, they can only be equal if the two exponents are equal. So therefore, the x would have to equal 4, and that would be our solution. So what we're trying to do is get both numbers to the same base, and then once we have the same base, we're going to set their exponents equal to each other. Let me give you another example. Three to the 4x minus 1 equals 27. What if I have this exponential equation? I'm going to do this one, then I'm going to give you one to try. Okay. I see this side is written in base 3 because it's 3 to an exponent. Complicated exponent, but it's still, the base is 3, the exponent is 4x minus 1. So I'm going to go to the other side and write that in base 3 as well. So let's go. How do we do that? 3 times 3 is 9. 9 times 3 is 27. The ones I'm going to give you now, you're going to be able to do this. You're going to be able to write both sides in the same base. So this 27, remember how many times did I multiply 3 by? 3. So this could be written as 3 to the 4x minus 1 equals 3 to the 3. And now, since the two bases are the same, I can ignore the base and just work with the exponents. 4x minus 1 equals 3. Okay, so once you have the two bases the same, just get rid of those bases and just write the equation of the exponents. Well, this is going to be easy to solve, because usually then the next question is not so hard. This is not a hard equation. I get 4x equals 4, which gives me x equal to 1, and my answer for x is 1. Okay, here's one from an exam. Let's see if you could do this one. This is off a final exam. It's 4 to the 1 plus 2x exponent. 64. And here are your choices. A is -1. B is 4. C is 1. D is 16. Which of these is the correct answer for x? And if you want extra credit, put an answer on the chat. No guesses as to the correct answer? Okay, so then let's work on this together. And I'm going to show you two alternate methods of doing this. Let me erase this one so we have room to work. Method number one. We could use the answers and see which answer works. Let's say I pick A. Choice A is -1. That means I'll do 4 to the 1 plus 2 times -1 and see what that gives me. Well, this is 1 plus -2, which is -1. So that gives us 4 to the -1. Now, 4 to the -1, we know is 1/4. So it's not the right answer because it's not 64. Okay, now let's try choice B. 4 to the 1 plus 2 times 4, which will give me 4. This is 2 times 4 is 8 plus 1 is 9. 4 to the 9th. Now, 4 to the 9th, I'm going to try on my calculator and see what I get. Remember, there is a square root, but there is an exponent button. Most calculators' exponent button looks like this. If you want to do 4 to the 9th, you're going to put in the 4. You're then going to press your exponent button, which is, again, if you don't see that button, then you're going to have to show me a picture of your calculator so I can tell you which one is your exponent button. And then you're going to put in the 9. These are the buttons you push. And then you press equal. So I'm doing 4 exponent 9 enter or equal, and I get 262,144. Obviously, that's not the right answer. Okay, so now let's try choice C. Choice C is 1. So I'm going to do 4 to the 1 plus 2 times 1, which is 4 to the 1 plus 2, which is 3. And again, I'm going to do 4 exponent 3. And guess what it gives me? It gives me 64. I know my right answer is C, choice C. That's using your calculator, just picking your choices and seeing which one works. Alternatively, we could have done it the way we did the other one. Let me show you how to do it as if it was an open-ended question. And you have your choice of doing it either of these ways. We want to do 4 to the 1 plus 2 to the x. So this is being base 4. We'd like to get the 64 in base 4 also. So I start multiplying. 4 times 4 gives me 16. 16 times 4 gives me 64. That means that this has to be 4 to the 3rd. Again, these are going to be relatively easy numbers to work with, which means that the 1 plus 2x is going to equal the 3. And now I just solve this equation. So I get 2x equals 2. And of course, that gives me x equals to 1, which again is choice C. I happen to think this is the easier method, but if you notice, you could use you could make use of the multiple choice to find the correct answer as well. Let me remind you that the tutoring schedule for this week and next week with Patrice Williams is, well, today it's from 2 to 4. On Monday, it's going to be 12 to 2, and on Tuesday, it's going to be 1 to 4. It's in room L00 in the Science and Technology building. The math department is in that building. And this is on the first floor, at the end of the first corridor. So she does in-person tutoring that will make. Remember, you have less than 2 weeks to prepare for this final. Also, posted on Blackboard is the practice final. It's in the tests and quizzes section of our Blackboard account. You can have unlimited tries to that practice final. The best mark that you get, whether you try it once or you try it 5 times, the best mark that you get, I will count as a quiz mark, which will mean, I think, that we'll have a total of 6 quizzes. For your average for the term, I'm going to count the 4 best marks. So the more marks you have, the better chance you have of getting a good mark. So make sure you're working on that. Again, we haven't totally finished all the material for the final, but we're almost there. We're on the last section. We're going to be continuing with what we're doing on Monday. Does anybody have any questions that they want to ask me? Okay, then I'm going to wish you a happy weekend, healthy, and work on your math. Have a good weekend. Bye-bye.